Hi guys. So, I got some practice problems for you to work on this week if you want to keep yourself distracted and work on something and be busy. So, we don't really talk about circles in pre-calculus because, it's part of geometry, so they kind of skip over it. But, you know what, why not take this extra week and give you a chance to look at them and refresh yourself, because I know it's been a while since we've looked at circles, talked about circles, been in geometry for some of us. So this is a good way to do it. So remember that I told you the other day, when we talked about parabolas, I showed you this picture from our textbook. And a parabola or a conic section is just that if you took two cones that are on top of each other, in this case they called them double napped cones, uh, they, when you cut them, you get certain slices, certain shapes when you cut it. So like for example here, when I cut it horizontally, you end up with a circle, which is what we're going to talk about today. If you go slightly diagonal on a horizontal cut, you end up with an ellipse, which we're going to talk about next week. If you cut it a little bit more diagonal, so that it also goes through the base or the top of the cone, you end up with a parabola, which we talked about before spring break. And if you cut it perfectly, cutting it vertically so that it goes through the top cone and out the bottom cone, you end up with two parabolas, one going up, one going down, and we call that uh, uh, hyperbola. Whew, I forgot for a minute. So I think we put that here. Circle, ellipse, parabola, and hyperbola. Boom. So circles look very similar to you're going to notice a lot of them look very similar. It just kind of has to do with if there's minus signs, if there's 1 squared or 2 squareds. In the case of a circle, we're going to have x minus h squared plus y, that's a y, minus k squared equals r squared, where h and k represents our center, which is the same thing we had for a parabola, right? And r is the radius. We have something called a locus, which I think maybe off just looking at parabolas and circles, you'll kind of see that. But as we look at the ellipse and the hyperbola, you're going to really see how apparent this is. Every single one of our conic sections, where's my pen? There it is. Every single one of our conic sections has this really special property that there's a focus point or a directrix or multiple focus points, and what happens is those points create cool things that happen with your figures. So for example, in a circle, circles will have a center point that is equidistant from any point on the circle. So any point you choose on the circle, it will be the same distance from the center, which we know, right? That's like what a radius is. The center is always equidistant from all the sides because those are radii of the circle, and the radii make up what the circle is. With parabolas, we talked about how if you chose any point on the parabola, if you found the distance to the focus and found the distance to the directrix, those two distances would be equal no matter what point. When we go on and talk about ellipses have 2 points, and if you add the distances from those 2 points to any point on the ellipse, it'll be equal. And hyperbolas, if you take any point on the hyperbola and find the distance to, again, it has 2 focuses, find the distance to the 2 focuses and subtract them, you'll get the same number. So as you go through, you'll see that kind of thing that happens in every single conic section. We call that the locus. Like whatever property that is, it's the locus of that conic section. So let's go ahead and look at this first example then. And I'm just going to kind of go through and do like one example of each of these with you so you can look at them and then try the other one yourself. So here it says identify the center and the radius of each circle and then graph the circle. So what's important to know is that this formula is x minus h, y minus k. This minus right here has a big effect on the actual thing, because right here when I plugged a number in, it kind of looks like there's a -1 right there, right? You see x minus 1. It looks like a -1. But if I plugged a negative 1 into this equation for h, you would get x minus negative 1. So it would become x plus 1. So what happens is the number that's plugged in is the opposite of what it looks like. So for example here, the center is coming from this negative 1 and this negative 2. But that's really a positive 1 and a positive 2 to plug into the formula to get the right numbers. So be mindful of that as you work through these. Any sign that you see, you always switch it. Also make a note that if there is no number next to it, like here where you see just x squared, and I did a couple of these in class, but if it's just x squared, well, it just means that it's plus 0, right? It's x plus 0 squared. So the x value is at 0. So that can kind of help you there. The radius is coming from right here, right? This number right here represents the radius. But what's important is that that number represents r squared. So we have to find what r was to make 64. Well, that's pretty easy. Then we just take the 64 and square root it. I'm going to get really good at this soon. Square root it, and we get 8. So I know that the radius is 8. So I'm going to graph this point first. Over 1, up 2. Okay? And then since my radius is 8, I need to go every spot that's 8 away. When doing that for graphing a circle, what's the easiest thing to do is probably just count 8 away from the point in 4 directions. So I'm going to go 8 up first. So 1, 2, 3, 4, 5, 6, 7, 8 right at the top here. Oh my gosh, I got to make it stop doing that. 8 over, which is also going to put us at 10. 8 to the left, 1, 2, 3, 4, 5, 6, 7, 8. And then 8 down, 1, 2, 3, 4, 5, 6, 7, 8. And then you do your best to draw a circle there. Let's see if I can just, I'm going to cheat. I'm going to cheat and draw my circle. Click circle. Where do I start at? Do I start here? Oh, nope, that doesn't work. Let's see. Let's see if I can do it here. Ah, forget it. Forget it. We're just going to draw the circle the best we can. That's a perfect circle. I did really good, guys. You could do better, I'm sure. But pretend it's a circle. Do your best to make it nice and round. But that's it. That's what we do. All right, next one says rewrite the equation in standard form, then identify the center and the radius. I'm going to do 2 here real quick, just because I want to make sure we get a chance to see both of those. Hold, please. The dog wants out. See, I'm going to be distracted working from home. They're going to want things from me. I'm going to do 2 just because there's 2 examples here that I think are worth noting. Firstly here, you can see that in this first example, they asked me to rewrite this in standard form and identify the center and the radius. Well, the problem is that standard form means that there can't be anything in front of the x squared, the y squared. They have to be equal to 1. So pretty easy then. We're just going to divide by 3 on everything. And I'll end up with x squared plus y squared equals 64. That was 128. 130. Yeah, 64. So at that point, I'm done. I know the center here is at 0, 0, because there's nothing being added to x, nothing being added to y. And just like we did up there, we square root that radius squared, and we'd get r equals 8. So if you look over here, this one might be a little bit more challenging. And the reason, not even. Nah, we're not going to do that one. That one will be easy too. Well, let's look at this one, because this one's going to be where you actually need to do what it says here. Note, you may need to complete the square to do some of these equations. This would be one that you'd have to do that. So what we're going to do is we're going to rearrange our numbers so that they're together. So I'm going to move this x squared and this plus 6x together. I'm going to move this plus y squared and this plus 2y together. I'm going to move this 6 to the other side, so it's going to become negative 6 on both sides. And from there, I'm going to do my completing the square step, which we did this with the parabola. The difference with the parabola is I think we only had to really complete the square with one number, right? You only ever had to do it with one thing. Here, I have 2 things to complete the square with. So I'm going to start with the x's first. If I want to complete the square with the x's, I'm going to take that 6, divide it by 2, and I get positive 3. And then I'm going to take that number and square it. And when I square positive 3, I get 9. So I'm going to put plus 9 after the 6x. If I add 9 over here, I have to do it over to the right-hand side, right? That keeps the equation balanced. We can add 9 as long as we add it to both sides. Next, I'm going to look at the y's. And with the y, I've got this positive 2, so I'm going to take that positive 2 and divide by 2. Note that it is super important that you pay attention to the sign here. If it's negative, you have to divide by negative. If it's positive, make sure it's positive. But you always divide by 2. We always want to cut it in half. So 1 squared is going to give me 1, so I put plus 1 here and plus 1 over here. And now we can go into actually solving this now. We're going to factor this part right here, x squared plus 6x plus 9. Well, that's easy. It's going to factor into x plus 3, because that's half of 6 and the square root of 9. I purposely did that by creating the square. So we know it's going to factor into that, x plus 3 squared. Plus, over here, we know it's going to factor into y plus 1. And that's why that negative matters. If there was a negative there, it would be y minus 1. And over here, we just add this together. Negative 6 plus 9 is positive 3. Positive 3 plus 1 is 4. And from there, we can get everything we need. The center is at negative 3. Remember, it's the opposite, and the opposite, negative 1. And the radius is equal to the square root of 4, which is 2. Pretty easy. And coming down here, this shouldn't be super hard either. It says, write the center. Given the center and the radius and a radius or the diameter, find the equation of a circle. Well, super easy. We know when we plug this in, it's x minus negative 2, so it becomes x plus 2 squared. Plus, since it's y minus 7, negative 7, it's going to be y plus 7. And it equals the radius, oh, I forgot my squared, equals the radius squared. So we take 16 and square it, and that's going to give me 256. Boom. That's it. Done. Do be mindful that when they do down here, like here where they give you the diameter, you're going to have to cut that number in half before squaring it. If you square the 24, you're going to get the wrong answer over there. Over here it says, given the center and the circumference, or the area, find the equation of a circle. I'm not going to really go into it because it's really much just like this. What I will tell you is that there's two formulas you got to know, right? The circumference is equal to the diameter times pi. Or you can say 2r pi. 2 times the radius times pi. I think thinking about diameter pi is easier because then you know, like giving you the answer right here. Look, if this says 10 pi, you know the diameter is 10. Boom. You could do exactly what you did up above. The area is equal to pi r squared. So you know that the number they give you in front of pi in the area problems, well, you just take that number and square root it, and then you have the radius. And then I think most of that's pretty easy. These give you some challenges. The dog wants in. Hold on. Hello, dog. Okay. These ones just present some challenge questions. I think I'm going to just kind of leave those for you to try. Like in this problem, they give you the center on all of them, or sorry, on the first 4. The problem is that they don't tell you on here what the radius is. But if you know the center and the point on the circle, you can find the radius by using the distance formula, which if we don't remember what that is, it's going to be x2 minus x1 squared plus y2 minus y1 squared, and then square root whatever number you get there. And that's how you solve those ones there. For these ones down here, they gave you 2 points on the circle, given 2 endpoints of the diameter. So they didn't tell you a center, nor did they tell you the radius. So you're going to have to use the distance formula on the 2 points to find the diameter, and then cut it in half for the radius. But to find the center, you're going to have to find the point in the middle of the 2 endpoints. And so if you don't remember that one, it's x2 plus x1 divided by 2. And then separately do y2 plus y1 divided by 2, and you'll be able to do that. So I'll leave those for you. Again, though, if you have any questions on any of that, there's some homework problems down here, too, that go with it that you could try out. If you have any questions, please send me a text, send me a message on Edsby. I'll respond to the text quicker because it pops up on my phone. Edsby does not. I have to actually log in to look at it. So you're probably best to send it to me on my Google Voice number, and I can help you out with it. So good luck. Let me know what I could do. Bye, y'all. I hope you enjoy your extra week off of relaxing and fun-ish. Okay, bye.